In this video, I'm going to explain how to solve algebraic equations with fractions. It's also called solving rational equations. Rational means fraction, rational, fractional. For some reason in math, we call fractions rational sometimes. So I definitely recommend watching videos and practicing a lot at it where you add and subtract fractions with unlike denominators, where you have to find the LCD. You want to get that down a lot. This is one way that you can solve these kinds of equations, which this video is about, is by using that skill, adding, subtracting fractions, and making the denominators the same. You can do it that way. I'm going to show you a better, different way that my students seem to like, where we get rid of fractions immediately, and the next step we have no fractions. So that's what I'm going to show you. So we do need to find and determine the LCD for this. We have -6 equals y plus 5 over 9. We really only have one denominator that's not a 1, so the LCD is 9. So what we're going to do is get rid of that fraction right away. So I'm going to write this problem again, because what we do when we write our math work is write the original problem down and then work on it and show what we do in each step. This way I can see what the original problem was by working on this line. So the LCD is 9. What I'm going to do is multiply every term by 9. And we'll stick that right in there, both sides of the equation. See, I'm going to distribute the 9 to each term. Every term gets multiplied by 9. And so that means 9 times -6 is -54. And then what we have is 9y, 9 times y, and 9 times 5 ninths. I'll take it over here so you can see what that looks like. Really, 9 over 1 times 5 over 9. What happens when we multiply fractions is that we can cross cancel, and that really just leaves a 5. 5 over 1 or 5. So this is plus 5. Isn't that much nicer? Here's our problem, and we immediately, in the very next step, made the fractions go away. So then we know what to do there. We need to get y by itself. We want to find out what that value is. And so we need the 9 to go away from y, and we need the 5 to go away from y. But we start with the 5 first, kind of the thing farther away first. So we have to think, how can we make this 5 disappear from this side and appear over here so that we can combine it with this like term? And that is to subtract. So we're going to subtract 5 from both sides. We have to do it to both sides. It's a property of equality. And that will make this 0. This equals 0. So 9y plus 0 is just 9y. That's how that disappears. We have to do what is needed so that make that disappear. And then -54 minus 5 is -59. And so we have -59 equals 9y. And we still need that 9 to go away from y. So I'm going to take that over here and work on it. Come on, internet, work with me. I need the 9 to go away from y. This is extra work there. So what I'm going to do, since 9 is multiplied by y, I do the opposite operation and divide by 9, by exactly what I want out of there. And I have to do it to both sides. And so what happens is these cancel, and I have -59 over 9 equals y. A weird looking answer, but sometimes that happens. As long as this is reduced, you have to make sure that nothing goes into 9 and 59. I think that's it though. So that'll be it. So let's do another example. If we have v plus 4/5 equals 1/3. So now we have a couple fractions instead of just one fraction. So we have to find the LCD of all these denominators. So your LCD is always going to be the biggest number or bigger than that number, never smaller. So if 3 doesn't go into 5, I've got to think of a multiple of 5. So next multiple of 5 is 10. 3 doesn't go into 10. Then you have 15, and 3 does go into 15. So the LCD is 15. So I'm going to use that LCD, and I'm not going to do anything like I'd usually do with these fractions. I'm going to write this problem again. Remember what we do next with the LCD? We're going to multiply each term by the LCD. So these two terms, you can write 15 here, or you can just write parentheses because that means you're going to multiply both by 15. That needs to be multiplied by 15, and this needs to be multiplied by 15. So 15 times v is 15v, and then 15 times 4 over 5. So that looks like this. Take this aside if you need to. And you're multiplying fractions. So 5 goes into 5 one time, 5 goes into 15 three times. That looks like 12. 12 over 1 or 12. So that gets replaced by 12. Equals, and now we're looking at 15 times 1/3, which you might be able to see what that would be already. Is basically 15 over 3, or you can cross cancel and see that would be 5. So that gets replaced by 5. Now you have an equation with no fractions. Much better. So again, we're trying to solve for v. We need the 15 to go away from v to the other side of the equal sign. We need the 12 to go away from v to the other side of the equal sign. You start with the number farther away from v first. So the way we would get rid of that 12 is by subtracting the 12. We have to do it to both sides. So we'll subtract 12, and from both sides. And so this part makes 0. 15v plus 0 is just 15v. And 5 minus 12 is -7. Whatever it comes out, the answer comes out to be, you do your algebra work in the same process that you know. Doesn't matter what the answer is supposed to look like. You can't discriminate how an answer should look. So that's what we got. Now we need the 15 to go away from v. And so we're going to divide both sides by 15. That's because it's being multiplied by v, so we need to do the opposite operation and divide. That'll allow these to cancel out. And what you have is v equals -7 over 15. And that's it, as long as that fraction's reduced. I definitely have another one. We need to look at multiplying these things, but first I want to make sure that you realize that when you have something like half x, like this fraction as the coefficient or right in front of the x, that's the same thing as 1x, or we would just write x over 2. We really don't write the 1. You can put the x to the side, or you can put it with the half up there. Here's another example. 4/5 y is the same thing as 4y over 5. It's the same thing. So it's as if this y is over 1, and then you multiply fractions straight across. I'll make up another one. 1/3 a. Let's make this a 7. What the heck? 7/3 a is the same thing as, what do you think I'm going to write? You can pause the video and think about it if you want. Is the same thing as 7a over 3. So the a beside the fraction can go up with that. Just remember that kind of arrangement. So now here's my example. 5y over 3 equals 15. The y's are already up there. If you may have some problems where the y is out here, so that's why I want you to be prepared for that. So what you can do with this, if you have a fraction equals one number, there's many ways to actually do this. One way that I'll show is just remember you can multiply that bottom number by that whole number. You can't multiply the top by this whole number by the top. It has to be the bottom. They can multiply. And then you would have 5y equals 45. And you can just think 5 times what is 45 because that's part of our multiplication tables. Or you can write this out and do this algebraically where we want the 5 away from y because we're solving for y. So we're going to divide by 5, both sides by 5. And these will cancel. And then you're looking at 45 divided by 5, which we know is 9. So you might see these kinds of problems as well. Here's another problem. 3u equals 9 over 5. So there's a few ways to do this probably. Now you're looking at the u. We want u by itself so we can see what value it represents, just like this y in the end. The 3 needs to go away from the u. So since 3 is being multiplied by u, we've got to divide it. So we divide by exactly what we want away from u, which is 3. And we have to do it to both sides. So now what happens is that these cancel and allow u to be by itself. 3 divided by 3 is just 1. 1 times u is just u. And over here we have 9/5 divided by 3. So you can write that like this. 9/5 divided by 3. Or you can write u equals 9/5 divided by 3 over 1 to recognize that as a fraction. And of course with fractions, when we divide, we change it to multiplication and flip the one on the right. And I'm going to bring this right up here. U equals, and so we can multiply fractions straight across unless we can cross cancel. We can do that now. So 3 goes to 3 one time, 3 goes into 9 3 times. So you have 3 over 5. U equals 3/5. Okay, so replay that if you need an explanation. I'm going to go over a couple more variations of these, and then you might want to go on to the next video to see some more complicated rational equations to solve. So if we have negative 42 equals negative 7/4 y. Just think as if this is a whole number. What do I got to do to get y by itself? Negative 7/4 is being multiplied by y, so I'm going to write this line again so I can work on it. This way if I go back and look, I can see what the original problem was. I don't have to decipher it out of a bunch of mess. So negative 7/4 is being multiplied by y, so we're going to do the opposite operation and divide by negative 7/4. Exactly what we want out of there. And so we've got to do it to both sides. So what happens is when you have a number over itself, they cancel out. And that allows the y to be by itself. And then over here we have negative 42 divided by negative 7/4. And so what you do with fractions, which this is really over 1, so negative 42 over 1, we change it to multiplication and we flip the one on the right. So times negative 4 over 7 equals y. And we look to see if we can cross cancel. Cross canceling helps us to not have to reduce in the end so much. Sometimes you still do, but 7 goes into 7 one time, 7 goes into 42 6 times. So then we can multiply straight across. I'm bringing this right up here. I'm going to put y equals on this side. Same thing. So we have negative 6 times negative 4. Which you can see that's going to be positive 24. So y equals 24. Okay? I'll do another kind of fraction equation, fractional or rational equation. If we have 5y over 9 equals negative 20. We want y by itself, so that 5 and the 9 need to go away. So the first thing before I write this, I want you to remember when you just have a fraction equals some whole number, this isn't a whole number technically, but some just number, not a fraction, and added something else, you can just multiply this by that. You can't multiply these two. It only is correct to multiply these two. So what I have is 5y equals negative 20 times 9, which is 5y equals negative 180. So now I need the 5 to go away from y. So you'll start to see this faster, what you're supposed to do. Since 5 is multiplied by y, you got to divide by 5. Got to do it to each side. So these cancel. And y equals a negative number. Negative divided by positive is a negative. -36, negative 36, 30, 15, 16, 17, 18. Yeah, I think so. I was doing that in my head. So y equals negative 36. So there's some smaller, shorter fractions, equation with fractions where you're multiplying. I want to show you one other type of equation, but I'll do a couple examples of this, and that's it. So if we have, say, negative 54 plus x over 5 equals negative 7. See how the x is tied up in here? You can't just separate the negative 54 out in the 5. But remember, we really do just have a fraction equals this big number here. So you can multiply these two. And in fact, that will get rid of fractions right away. So the top will equal that. So negative 54 plus x equals 7 times 5, just like I did before. Whatever's up here is right here, and that equals these two multiplied together. There should be negative 7. So we simplify the right side. Negative 54 plus x equals negative 35. And then, so we want x by itself, and we want the negative 54 to go to the right side. So we're going to have to do something to make that happen. So I'm going to make some room, and you can think about what we need to do to make that 54, the negative 54, disappear from the left side and appear on the right side. So what we would do is add 54, and got to do it to both sides. I would not write that in down here below the problem, because you'll end up accidentally thinking that's division. I don't like when teachers do that or allow that. Move these things over and squish these in. So this equals 0, and 0 plus x is just x. That's why I chose to add 54. So x equals whatever negative 35 plus 54 is. So I have to subtract those numbers. Looks like a 19, positive 19. So x equals positive 19 out of all that. Now I will do another problem where I have negative 8 equals negative 53 plus x all over 5. See how that looks? So you can pause the video and think about the answer to this question. What do I do first? So now I'm going to tell you what I'm going to do first, what there is to do. Multiply these two and set them equal to the top. That big number can be multiplied by that. So negative 8 times 5 equals whatever's on the top, all of that. It can be one number, it can be a bunch of stuff. That's how it goes. Always the same process. So then negative 8 times 5 is negative 40. So you have equals negative 53 plus x. So we want negative 53 away from x. So I'm going to write in whatever I need in order to do that. I'm not going to write it down under here so it looks like it division. So you need to be able to go back and read your work, and you need to, be able to not accidentally make a careless error while you're doing your work, and other people, including your teacher, needs to be able to read what you did. So anyway, we need this negative 53 to appear on the left side. The way to do that is to add 53, and have to do it to both sides. Okay? So then negative 40 plus 53, it's like you spent $40 and you put 53 in your account. So where you at? It'll be a positive number. 53 minus 40, 13. So positive 13 equals, and this part is 0. 0 plus x is just x. So x is 13. 13 equals x equals 13, whichever way, doesn't matter. Same thing. Okay, so I hope that helps.